So the question is, how can we prevent aliasing from happening? One is we could get more samples. Okay, we can join the megapixel craze in the current video technology. My birthday's coming up this month, and I treated myself to a new camera. And the camera has 36 megapixels in an image, all right, so that I can pull out really fine detail in a portrait. But in general, the sort of the megapixel thing doesn't go on forever. You know, stuff always can wiggle faster and faster as things get further away, for example. So what do you want to do? Well, what you want to do is you want to make sure your signals are less wiggly. That is, they don't have all that high frequency component. You want to get rid of some of that information. So the idea is we're going to get rid of some of the high frequency information, but that's going to be better than aliasing, right? The idea is we don't want to see that weird checkerboard effect, right? So we're going to remove some of the high frequency, but the idea is that the thing will be well behaved. So let's talk about that real quickly in our audio example. What we're going to do is we're going to introduce low-pass filters. And what the low-pass filter is going to do is we're going to put that right here, so where the analog voltage is coming out of the microphone, so that the signal that goes into the A to D converter doesn't have frequencies higher than a certain amount. We'll say, okay, great. So that says that we can reduce the number of samples we need to take, or limit the number of samples we need to take. And then when we do the reconstruction, we'll know that anything that was reconstructed that was of a higher frequency than we let in should be thrown away. So we use the low-pass filter again for the output to the speaker.